Example 1. In the diagram, the particle is in equilibrium, and we need to find the values of P and theta. So we have four forces acting on the particle, and one of those forces is at an angle of theta to the horizontal. The first thing we need to do is decide which direction should we resolve in first. To do that, we consider how many unknowns we would have in each particular direction. Let's consider the vertical direction. We've got P acting downwards, and we've got a component of this 12 Newton force acting upwards. That means resolving vertically, the calculation would involve P and it would involve theta. However, if we resolve horizontally, we would still have a component of the 12 Newton force acting to the right, but as P is acting down the page, it does not have a component to the left or the right. Therefore, we'll start off by resolving horizontally. We're going to resolve to the right as the positive direction. Let's first consider the component of the 12 Newton force. We want to find the component to the right, so we are crossing the angle, and that means we should be using cos. So we have 12 cos theta. We have a 6 Newton force to the left, so that means minus 6 goes into the calculation. The 5 Newton force is acting up the page, so we can ignore that. And the force labelled P is acting down the page, so we can ignore that. So the resultant force is 12 cos theta minus 6. As the particle is in equilibrium, mass times acceleration is 0. Next, we rearrange to find theta. We'll add 6 to both sides to get 12 cos theta equals 6. And then we'll divide by 12. 6 divided by 12 is 1/2. Inverse cos of a half is 60 degrees. Now that we know the value of theta, we can resolve vertically to find P. We'll take downwards as the positive direction. So we have P acting vertically downwards, and we have 5 newtons acting upwards, so that's P minus 5. We also have a component of the 12 Newton force acting upwards. As we're not crossing the angle this time, we'll be using sine. So we get minus 12 sine theta, where theta is 60 degrees. Again, acceleration is 0, so the right hand side is 0. Rearranging this, we get P equals 12 sine 60 plus 5. And if we put that into our calculator, we get 15.4 newtons to 3 significant figures. Right, now it's your turn to have a go at a problem. Pause the video, have a go, and then come back and check your solution against mine. Okay, welcome back. Here's my solution. To start with, let's consider which direction we should be resolving in first. If we work up the page, we can ignore Q because that is working horizontally. So resolving with upwards as the positive direction, we've got 6 newtons working upwards. We've got a component of the 8 Newton force. As we're not crossing the angle, that will be 8 sine theta. We've got a 10 Newton force acting down the page, so that's minus 10. Q and the 15 Newton force are acting across the page, so can be ignored. Particles in equilibrium, so we get 0 on the right hand side. Rearranging this, we get 8 sine theta equals 10 minus 6, which is 4, which gives sine theta equal to 1/2. Inverse sine of 1/2 gives us 30 degrees. Now that we know theta, we can resolve horizontally to find the value of Q. We'll take right to be the positive direction. If you've chosen the left, it doesn't make any difference, you'll still get the same answer. So we have Q acting to the right. We have a component of the 8 Newton force. We're crossing the angle this time, so it will be 8 cos theta, where theta is 30. In the other direction, we've got a 15 Newton force, so that's minus 15. and the 10 Newton force and the 6 Newton force are acting up the page, so can be ignored. Rearranging gives us Q equals 15 minus 8 cos 30. And if we put that into our calculator, we get 8.07 to 3 significant figures.